So in our last class, we were discussing polymorphism. So I will come back to polymorphism. Just before that, I just want to just say one more thing. So make sure that you actually keep track of the topics that we have learned. So some of you are still confused between function overloading and function overriding. And then we have learned about virtual functions. Okay. Then we have abstract class, pure virtual function. So it's very easy to get confused between them because there are so many things going on at the same time. So I will try to clarify them one more time, but let me first finish the polymorphism. Let me give you the basic idea of polymorphism. Today I will show you two more cases with an example of how polymorphism work. So let me go through the definitions that we have given. So in our last class we have talked about that what is polymorphism. It is the process of representing one form of unique in multiple forms. Okay, so there was an example for it, that this polymorphism actually came from the Greek words poly and morph. Poly means many, and morphs mean form. So if you have many forms, we call it polymorphism. And then there's a real life example that we discussed, that suppose if you're in a classroom as then you behave like a student. If you're in a market, then you behave like a customer. If you're at a home, you behave like a son or daughter, or other person. So that means depending on where you are, your behave function actually acts differently. So as a human, then we talked about another function that is called dress function. So depending on whether you're in a classroom, you dress in one way. Depending on whether you're in a market, you dress in another way. If you're in home, you dress up in another way. So this is the polymorphism. That means even though the function is same, but we are actually calling different, name of the function is same, we're calling different definition or different code at different time. So that was the example. So here is another. So this is the same person in the customer shopping mall, he behaves like a customer. So the behave is the name of the function here. Then in the bus, he behaved like a passenger, like exactly how the passenger should behave. Then in school, he behaved like a student, and home, he behaved like a uh, son. So if I talk about what does this behave mean, that means in the shopping mall you can walk around, you can run. Okay, but in the bus you cannot walk around. When you go to the bus, you have to sit in a seat. Okay, then when you go to the school, okay, you cannot just talk to your friends. Just like whenever you go to shopping mall, you can roam around, you can talk to with your friends. It's not allowed in the classroom, right? When you are in home, you can do whatever you want. Okay, but still there are some certain rules you have to maintain. So polymorphism in short is the, we want, this is the feature that as a normal real world human or real world objects have, that depending on where the object is, it actually acts in a different way. So this is real life. So this is a real life scenario. So what we're trying to do here, we're trying to implement this real life scenario in case of our programming, and that is where the polymorphism is. So when we want to implement this real life scenario, the object, this the behavior of this objects to our program, we use polymorphism. Now how we can do it? So we have seen that there are two types of polymorphism. One is a static polymorphism, another one is static, and one is a dynamic polymorphism. So we have seen that to implement the static polymorphism, let me show you the screen. Mm, where was it? So to, yeah, to implement the, we have two way. Okay, so compile time is the runtime. So for compile time, we use function overloading, and operator overloading, there is also the is as well. And the runtime, we use virtual function. So we will talk more about what is a virtual function and how it works. And in the compile time, we have function overloading. You're already familiar with function overloading. Okay, so back to it. So we have this two type of static polymorphism and the dynamic polymorphism. Okay, so there's another name for it. The static is called early binding or compile time polymorphism, and for the dynamic we have late binding or runtime polymorphism. So we will see that what does this exactly mean, that runtime polymorphism, early binding or compile time, and late binding or the runtime. So we will explain with an example. Before going to the example, let me show you a code. So let's think about compile type polymorphism. So we have this two way. One is method overloading and method overriding. So we already know about what is overloading and what is overriding. We have talked about this, and we have already also practiced some of the features for overloading and overriding. So in this overloading, or whether it's overriding, okay, we call it compile time polymorphism. So this is the first example of function overloading. So here, as you can see, we have uh, this is our main class, integer main, and we have this class. So in this addition class, we have two sum function. In the first sum function, we have a void sum, which take two integers and sum their results and print it. We have another sum function that takes three integers, and then it actually add the results and print it. Now, whenever we are running the program, look here what we're doing. Okay, we first declare the object, and then what we do, we actually write object dot sum 1020 and object dot sum 102030. So what this line, two lines exactly does, they actually see that this is a sum function, and in this sum function, what happens? Uh, we have two parameters, so this will go here, and between these two function it will call this one, because it one has two parameter. Same goes for this one, it has three parameters, so it will call this function. So this is function overloading. Now why this is called compile time or early binding? Because exactly here, by seeing this code, okay, the compiler can understand, okay, so this is a sum function, object dot sum, that means I have to call the sum function, and there's two parameters. So that during the compilation of the code, the program can understand I have to call this function. So this is called early binding. So if I go to the next slide, I think, so both functions have the same name but different parameter, and the compiler can understand exactly during the compilation, okay, that I need to call this one and I need to call this one. So that's why it's called early binding. Now, then what is the late binding? Let's assume, okay, I am just calling the sum function, but we don't have the idea that what will be the parameters. The user will give the parameters. Okay, in that case, we can call it runtime or late binding. So when we decide which function to call during compile time, it's called early binding. And when we call a function, decide to call a function during when the program is running, that's called late binding or runtime binding. So one more time, what is the binding? Binding is a process that decides when we call a function or when we decide to call a function. Early binding means during the compilation, we will decide which function to call, and late binding means during the runtime, we will decide which function to call. I will come back to this later, but for now, this is the idea. Okay, now here is then the method overriding. So before going to the overriding, first thing you have to know, what are the requirements for overriding? I have asked these questions to some of you, you couldn't answer this during the Viva. So first of all, what is overriding? So when the parent class and the base class, that means the parent class and the derived class, have the function or a method with same name, same parameters or signature, this is called method overriding. So the parent class, that is our base class, and the derived class or the child class have a function with same name, same parameters and signatures, that we call method overriding. And what are the requirements for overriding? First of all, inheritance should be there. Without a parent class and a child class, there cannot be any overriding. So this is point number one. Try to remember it. For overriding, inheritance should be there. Functions overriding cannot be done within a class. Okay, we require a derived class and a base class. So without a derived and base class, there cannot be any function overriding. Number two, the function that is redefined must have the exactly same declaration in both base and parent class. So that means the signature of the function must be same. So same, it has to have same name, same return type, same parameter. So you cannot change anything in the declaration. You can change the body of the function. So these are the two requirements for function overriding. If you just change any of this, okay, it will not happen. Now let's go to the another example. So this is a class, you see this is the base class and this is the derived class. So in this class we also have a show function, we also have a show function. So first thing, the first condition was what? That we have to have a child class and a parent class. So this, you see, we have two classes. So this is the first condition for overriding. What is the second condition? The second condition is that the return type should be same. The return types are same, the function name is same, function name is same, and the list of parameter which is not here, okay, they also should be same. So if I pass one integer here, I have to pass one integer here. So in this way we can override a function. Now let's go to the main function. Now this function call binding with class objects, if you just focus on this two, okay, so when it's done before the program is run, it's called early binding or static binding or compile time binding. So you can see any of these three name, but the idea remains same. I can say it's early binding, or I can say it's a static binding, or set compile time binding. So this is one side, we have early binding, static binding or compile time binding. On the other side we have late binding, we have dynamic binding, we have runtime binding. So all these three are the same thing. Okay, this three and this three are same thing. So let me write them side by side. So we have early binding, we have static binding, we have compile time binding. So whatever the word is, okay, what is the answer? If we decide which function to call when we are compiling the code, is called early binding, it's called static binding, it's called compile time binding. When we decide which function to call during when we are running the program, is called late binding or dynamic binding or runtime binding. So this is our main part. And then we have some related study that's we have already covered. So this is another example. So the last example we have seen is this one. We had two function, sum, that is overloading. So in this one, whenever we declared the class, declared the function, we have passed two parameters. So the compiler can easily see that, okay, I have two parameters, that means I need to call this function. So this one can easily understand I need to call this function because I have two parameters and this one is two parameter, and this one can also decide, okay, I need to call this function. So this way it was early binding. Okay, now in case of overriding, it can also happen. So this is an example of function overriding, and as you can see here, we have a show class, we also have a show class. So how we can decide which one to call, because in case of overloading, one had two integers, another one had three integers. Okay, so we could decide, okay, so two integer means I will call the first function, three integer means I will call the second function, but here everything is same. So how we can decide that which one to call when we are compiling the code? So that's where this comes in. So we'll declare an object of base class, we have declared an object of derived class. So if I write b.show, that means I will call the show function of the base class. If I write d.show, I'll call the function of derived class. So we have done all this before. Okay, I just didn't say that what we are doing in totally. I have just shown you that how the overriding can be done, but we didn't talk about compile time binding or runtime binding, okay, because it would made you more confused. But now here, as you can see, that when we can decide from the code that which function to call, okay, before running the code, this is called compile time binding or early binding or static binding. And this is important for polymorphism. I'll come to that. I've just shown you a chart. Remember that we have first, we have the polymorphism. Under polymorphism, we have compile time and we have runtime. Under compile time, we have overloading and overriding, and under runtime, we have virtual function. So that's why I'm showing you how, again, how overloading and overriding work. So to summarize, overloading means two function will have the same name, but they will have different signature. And what does signature mean? The number of parameters will be different, the order of the parameters will be different, the type of the parameters will be different. If you remember, in one of the earlier class, I have shown you an example like this, that an add function, okay, so an add function with integer, two integer, another add function with integer float, another add function with float integer. So all these are different, they have different signature. Okay, and in case of overriding, it's not about the signature, it's about two classes. One is parent class, another is base class and derived class. They have the same function, okay, but the definition is different. If I call the show function parent class, it will print the base this one. If I call the derived class, it will print this one. So if I, let's go to the next slide, we will show. So here, after I run the code, what will be the output? So when we start the code, it will first create two objects. So when we run this b.show, it will print base class. So this will be the first printf. And when we print d.show, it will print the derivative, it will be the second print. So that's all about our overloading and overriding that we use in polymorphism. Now we have one last thing before we go to the virtual function. So we have talked about only this. Yeah, so we have covered this, so no problem. But now the problem starts. Okay, there is some problem here. Okay, so before discussing the problem, let me just pause a bit. Let's wait. Ajan is going on. Let's just wait 2 minutes. As I was saying, normally what happens, so we write this to create these two objects. In case of overriding, this is an object of base class and this is an object of derived class. So when we write b.show or d.show, in that case the early binding occurs. That means the compiler decides, okay, so this is an object of the base class, so I will call the base class function, and this is an object of derived class, I will call the derived class function. So this is normal. Okay, but what is the problem? The problem starts if we use a pointer. So normally this one, all this code are same. Okay, so this is a pointer to the base class and this is an object of the derived class. Now we have declared a pointer to the base class and we have created object of the derived class. Now we are assigning the address of the derived class in this B. So we know what is a pointer. Pointer is a variable that can store address. And when we write b equals to nd, so it stores the address of d. So basically what I'm saying in this line, I'm saying that b, from now on, I know you hold the address of the base class, but from now on you will hold the address of the derived class. Okay. So when we write this b.show, okay, it's supposed to call this derived class. Why? Because it is storing the address of the derived class, so it should call this class. But the problem is when you run this program, because of the early binding, that means b.show, the compiler decides, okay, b.show, so I will call the base class. So when you run the program, in the output it only calls the base class instead of calling the derived class. So it's supposed to print derived class. Why? Because in this b, I'm storing the address of the derived class. Okay, those of you don't remember how pointer work, just know that this is storing the address of d, and when you store the address of d, this becomes d. So it should call d.show, that means the derived class. But instead of doing that, because of early binding, the compiler have decided that, okay, this is b, so I will call b.show. Okay, it calls the base class. So this is the problem. So how we can solve the problem? So we can solve the problem using virtual function, and that's where our late binding comes in. Now we will skip the operator overloading right now. And we'll go to that. So now we will solve it using a virtual function. We will see one example how virtual functions solve this problem, or how late binding occurs. That's it. So before that, the basic term, virtual function is a function in base class which is overridden in the derived class. So virtual function is a function in base class which we override in the derived class. Remember, we talked about the diamond problem and how we use virtual keyword to solve the diamond problem. So in that class, virtual was the inherited keyword, and now we are using virtual as a function. So virtual keyword is used to make a member function of base class virtual. So we can make an inheritance virtual, we can make a function virtual as well. And this is used in case of late binding. So in late binding, function call is resolved at the runtime. Hence, compiler determine the type of the object at runtime. Okay, it doesn't do early binding. The problem we see in the last example, compiler decides previously that which function to call, and that creates the problem. So when we use the virtual keyword, compiler doesn't decide before. It's almost like saying this, that hey, don't decide before, let me finish and then decide which function to call. So I will skip this and go to the example. So we just add the virtual keyword before the member. Now Just the same example, you see we have this instead of show function you have this display function. In the parent class we have a, okay, it calls content of the base class, and the child class it prints content of the derived class. Now again we are creating an object pointer of the base class, we are creating an object of the derived class, and we are assigning b dot d. So we are doing the all of this at same, and then we are calling the b dot display. But what happens, we try to call this function, and now let's go to the next slide. So everything is same, we haven't made any changes. And when we run the program, early binding occurs just the way we have seen in the last case. Okay, so it calls the, even though it is storing the address of the derived class, it calls the base class. So it prints content of the base class, but it was supposed to print content of the derived class. So how to solve it, we just add one small change. Okay, what we do, okay, we just add the virtual word here. So look at here, so everything stays the same, we just added the word virtual. So when we add this virtual here, it actually solves the problem. So again I will go to the last slide, look at this program, void display, void display. And now in this one we have virtual void display, but this one stays same. You don't have to change the derived classes, you just have to change the parent class. And when you write this virtual word, the compiler will use the late binding, or this keyword will force the compiler to use the late binding, and then the problem will be solved. It will call the content of the derived class. That means then it will wait, it will check the address. After checking the address, it will see that it's from derived class, and it will store, print the derived class object. So in short, when we don't have the virtual keyword, what the compiler does, compiler, when he sees this line, he thinks, okay, this is b is derived parent class, so I will call this class. Okay, so even though in this line we have used b to store the address of derived class, it will still call the parent class. To solve that, what we do, we use this virtual keyword, and then when we use the virtual keyword, the late binding occurs. Okay, that means the compiler during running the program decides which function to call, and it calls the derived class. That's it. Now virtual class, we can after that we have not we solve it using virtual class, and after that we'll see some other more examples. But today